Next. Okay. The next phase of reaction is common reaction is deamination. We already discussed. Glutamate is a collecting agent, is a collecting point for all the amino groups, and through glutamate only we can get transamination. That means that the what we call end point of transamination is glutamate, and this glutamate will undergo deamination, what we call specifically oxidative deamination. Okay, and deamination is nothing but removal of amino group from amino acid in the way of ammonia. That means in the form of ammonia, the amino group from respect to amino acid will be removed, and these ammonia, that means the liberated ammonia, will be used in the synthesis of urea. Because ammonia is a toxic compound, we have to excrete it out through urea. That means synthesis of urea to ammonia, what called deamination reaction. Then through urine we excrete it out. And how it takes place? Then this deamination, say oxidative deamination and non-oxidative deamination. The word it implied, oxidative deamination is deamination coupled with oxidation, whereas non-oxidative deamination, there is no such oxidation, just directly deamination process. Okay. Here, in case of oxidative, again of two types, GDH mediated reaction means glutamate dehydrogenase. Number two, amino acid oxidases mediated reaction. And this oxidative deamination reaction will take place majorly in liver and kidney. Let us look into the GDH. How GDH, glutamate dehydrogenase. The word it implied, glutamate dehydrogenase. That means oxidation coupled with deamination. Say, first take L-glutamate. It is a common element, okay? Central core element. This glutamate subjected to, that means catalyzed by glutamate dehydrogenase. The unique property of this enzyme is it may use both NAD plus and NADP plus for generation of these reducing domains. That means NADH plus H plus and NADP plus NADPH plus H plus. That means NAD, so for representation I am drawing here, both NAD plus and NADP plus will be utilized for to get it reducing components, because it is oxidation now. NADH plus H plus and NAD or NADPH plus H plus we get it. It's not a single step reaction. The intermediate component we get, say alpha aminoglutarate, and this alpha aminoglutarate catalyzed in the same enzyme, that means glutamate dehydrogenase, ultimately become alpha ketoglutarate by removing ammonia. That means we have all discussed deamination coupled with oxidation. Deamination coupled with oxidation. Deamination coupled with oxidation. Okay, decoupled with oxidation. What exactly called oxidative deamination, and it is through enzyme glutamate dehydrogenase. Another way is what we call amino acid oxidases. Say that we have L amino acids. We all knew that proteins are nothing but the polymer of L-alpha amino acids. But plants and microbes do contain D-amino acids. We do not have molecular machinery to support the D-amino acids, but through diet we get, and the same will be subjected to metabolic reaction. Say first we listen about L-amino acid oxidases. Okay, L-amino acid oxidases are low in activity when compared to D-amino acid oxidases. Okay, pick here first take an L-amino acid. It will be subjected to specific L-amino acid oxidase, and finally we get alpha keto acid plus ammonia. The same component, we get alpha keto acid plus ammonia. The keto acid will be utilized in various that means they have different metabolic fates, maybe for energy generation, or as a precursor for glucose, fat, or for the synthesis of non-essential amino acids. And the ammonia will be utilized in synthesis of urea, and the urine will be excreted out. Okay, the thing is, these L-amino acid oxidases become, to catalyze the reaction, so that the L-amino acid become alpha keto acid. Okay, here FMN and FAD, that are flavoproteins, will be utilized here, and during this process oxygen becomes H2O2. That means oxygen becomes reduced to H2O2, hydrogen peroxide, and this hydrogen peroxide again become decomposed by catalyzed enzyme. So it's like cyclical reaction. We have already discussed, just like transamination reaction. FMN linked with oxygen reduction, and ultimately we will get alpha keto acid plus ammonia. With respect to D-amino acid oxides, we have discussed D-amino acids are present in both. That means they are present in plants and microbes, and at first they converted to alpha ketoglutarate by respect to D-amino acid oxidases, and these alpha keto acids, for example, okay, in general, okay, and they converted to, that means they are subject to transamination to become, that means to continue their metabolic pathway. So it is like D-amino acid oxidases is the first step for the conversion, for the convenient conversion into our biological machinery metabolic pathways. Because these obtained alpha keto acids from the D-amino acid oxidase catalyzing enzyme, we get the appropriate amino acids through transamination reactions. This is how they should with respect to D-amino acid oxidases. Okay. Then there is another way, non-oxidative deamination. Here some of the amino acids will be subjected to deamination without oxidation. That means there is no coupling of oxidation with deamination. Say specific for few examples you can take. Dehydrogenases mediated enzymes, desulfahydrogenases mediated enzymes, and histidases. Say dehydrogenases. Say how this is shown. Say particularly the amino acids like serine, they are hydroxy amino acids. Hydroxy amino acids like serine, threonine, homoserine. And they will be catalyzed by the enzyme dehydrogenases to get respect to alpha keto acids plus ammonia. The ultimate objective is to get respect to alpha keto acids plus ammonia. Ammonia will be removed and the keto acids will be haved in different metabolic fates depending on the requirement, either for energy generation or the precursor for glucose and fats or for the synthesis of non-essential amino acids. Okay. Say it is with respect to hydroxy amino acid, means for serine, threonine and homoserine. Then take another example. Desulfahydrogenases is with respect to sulfur containing amino acids like cysteine. We knew that it contains sulfur. It is sulfur amino acid. No? This here along with an ammonia we also liberate sulfur group H2S to get the pyruvate. That means they have specific keto acid. We have already discussed. Each amino acid when it's subjected to specific non-oxidative deaminases will get specific with respect to alpha keto acids and ammonia. Okay, and the same here, the cysteine become subjected to desulfahydrogenases. Desulfur for representing like this I'm saying. Desulfahydrogenases to get ultimately liberating NH3 and H2S. And similar to the histidase, the word it implied, histidase act on histidine to get ultimately the respective keto acid and ammonia. And this ammonia will be utilized in urea and ultimately it will be excreted out through urine. So we have discussed protein metabolism simply means amino acid metabolism, and the end product is to get urea. That means through ammonia, transamination, deamination through ammonia, then urea, then urea will be excreted out through urine. So it's about, so here deamination, transamination, though it appears to be different, but they occur simultaneous. That is why we used to say transdeamination. Transdeamination both takes place simultaneously. Transdeamination. Most important thing we with respect to conceptual and examination point of view is glutamate. Glutamate is a collecting compound of nitrogen, or otherwise called collecting compound for amino groups. It is only amino acid. That means it is the end point of transamination. And this glutamate will undergo, that means deamination and all that, ammonia and all that. And most important, second important point with respect to transamination and deamination reaction is PLP, pyridoxal phosphate. This is important coenzyme of vitamin B6. And this coenzyme we have discussed, shift base. And this become pyridoxamine phosphate. We transfer the amino group to a second keto acid so that it becomes a second amino acid in glutamate with respect to transaminase. Say for example alanine is glutamate pyruvate transaminase. So it's like simultaneous process. Transamination, deamination, then ultimately ammonia, the ammonia will be urea, then urine, then the respective alpha keto acids, it may be used depending on the requirement, like energy production we have discussed. 10 to 15% of body energy requirement comes from the oxidation of amino acids, and the same time act as precursors for glucose, between carbohydrates, fats, and also synthesis of non-essential amino acids. Okay, we have discussed during this about these issues about when we discuss about amino acid inputs and outputs. This is about the central dogma of amino acid metabolism. Okay, thanks for watching.